Hi everyone, welcome to Real Science Challenge. I'm Kent Louie, science teacher and talking head, talking about practices we can do in science education to make it real. That's relevant, engaging, and applied learning. And broadcasting from beautiful Vancouver, Canada. And this is episode 72. And a couple of episodes ago, I mentioned that some teachers are reluctant to switch to standards-based grading, or SBG, because they felt that SBG was less rigorous. And I shared how over 2/3 of my students actually found SBG to be equal, if not more rigorous than traditional grading. So today, I'm sharing 3 things I do to make SBG more rigorous. But before I continue, handouts for this episode are available at realsciencechallenge.com/EP72. And please subscribe to our YouTube channel. Now here's the thing. We, as teachers, are in control of how rigorous we make a course, regardless of what assessment system we use. You know, the truth is, any change to how we assess takes time to adjust, and that's the real challenge. So here are some things you can do for those who want to make SBG just as rigorous, if not more rigorous, than traditional grading. Number 1, you want to get students to go deeper. For example, I take old provincial exam questions that I've used on my tests in the past, and instead of just marking for correctness in a student's response, I ask for a greater depth of explanation. And this fits well with skills like communication or argumentation, which I can assess along a proficiency scale from emerging to extending. So for example, check out this old provincial exam question. Art and Bill both attempt to move identical 40-kilogram crates across identical rough surfaces. Art exerts an 80 Newton force by pushing down with the stick, while Bill exerts the same force by pulling up on a cord. Bill's crate slides across the ground, but Art's will not move. Explain this observation using principles of physics. So on a 4-level proficiency scale, emerging may have students saying that Art couldn't overcome friction while Bill did. That's emerging. Developing would add that this is because Art is pushing down on the crate while Bill is pulling up. Proficient would show through calculations why Art doesn't overcome friction while Bill does. And how about extending? Well, I would expect students to offer a situation where both Bill and Art move the crate. For example, maybe in the case where there is no friction. Students in my classes find this type of answer where they need to use science to justify and explain a phenomenon while also offering a counterexample to be very difficult and very rigorous. Number 2, you want to be creative with your questions. If there's something you want to assess students on, so for example, their ability to analyze data, then find a creative way to apply and assess that skill. So for example, recently, a colleague and I, shout out to Norm Jansen from Caribou Hill Secondary, came up with a series of test questions that go a little something like this. It has something to do with celery sticks, okay? You know how when you put celery in the fridge, at first it's very stiff, but over time it gets kind of bendy. We call that plant structure rigidity, FYI for this question, okay? So it says, graph A shows plant structure rigidity for a stick of celery that was left in the fridge. And it asks the following questions. Explain what is happening to the celery using what you learned about cell organelles. Now it says here, number 2, a piece of celery was found in the back of the fridge. Its plant structure rigidity was measured at 85%. How long has the piece of celery been in the fridge? And finally, number 3, it says if both a carrot and celery were placed in the fridge at the same time and for the same duration, draw a graph that shows the plant structure rigidity of a carrot. Does it differ, or how does it differ from that of celery? Please explain. But wait, there's more. Here's a fourth question. Whoa, that's already pretty detailed, but here's the fourth one right here. It says, assume the table on the right shows the plant structure rigidity of a carrot left in the fridge over time. Which vegetable, carrot or celery, maintains its structure rigidity better over time? Use the CERR, claim, evidence, reasoning, rebuttal framework to craft an argument. Now these questions aren't found in any test bank or textbook. In fact, we just hashed it out over a 30-minute discussion. But the questions require students to analyze, predict, communicate, a lot of the skills assessed in SPG, while also connecting to content knowledge about cell organelles. So be creative. Finally, number 3, give projects where students are required to iterate and demonstrate improvement. This requires creative thinking from students and for them to produce something that actually works, both of which are very difficult tasks. So for example, I give my students a solar oven activity where they have to make and test 3 prototypes, 3 solar ovens with improvements between each one. Now I require that there be improvements between prototypes, and this goes towards their planning and conducting mark. And so therefore, students need to bring in materials, they have to do research in ways that help them change their prototypes to heat water more efficiently. And again, this is no easy task, but great students will rise to the challenge, and this is very vigorous. It's hard to do. That's it for this episode. Please smash the like or subscribe button below or leave a comment. And handouts, once again, are realsciencechallenge.com/EP72. Thanks for watching, and let's talk science education again soon.